again for joining today's talk. My talk is going to be about testing the Moz500 top websites and how you can use artificial intelligence and other big data tools to help you along the way. So first of all, just a little bit about me. I actually come from the programming side, not from the testing side, so don't hate me for that. I've been a programmer since the age of 10. I've always loved technology. I've been working professionally in the IT industry for 25 years. But before that, I was, as a child, as a kid, as a high schooler, I was writing software, and you can even find some of my computer games online that still run in emulators today. Currently, I'm the founder and CEO of Inflectra Corporation. Inflectra is a company that provides tools for test automation, tools for test management, requirements management, and risk-based testing. If you'd like to learn more about tools at Inflectra, you can go to our website. If you'd like to connect with me personally, I'm always interested in doing that. You can find me most actively on Twitter and LinkedIn these days. Twitter for short messages, and LinkedIn if you want to have a more in-depth conversation. But let's focus on the talk today. For today's agenda, I want to talk a little bit about why is test automation so hard? And I'm sure you want to know about this because this is a test automation series of webinars. And I'm going to be focusing really on web test automation, because really test automation itself can cover many different aspects: mobile apps, web apps, desktop apps, console, bots. There's lots of different kinds of test automation, APIs, and so on. But I want to talk specifically about web test automation and why is that so uniquely hard. And then I want to look at a research project that we did where we looked at the most popular websites called the Moz500. I'll explain what that is in a minute. And then using what we found from that research project, look at ways you can improve your test automation strategies. Some of this will be quite technical. We'll be getting down into the CSS and the XPath locators. So if you're a test automation person, you will love this. If it's something that you're maybe more of a novice, something you're learning, don't worry. There's lots of good general concepts. Some of the more technical aspects you can just park for later. And then I'll be looking at some specific tips and tools and techniques you can use. So, and then we should wrap it up with some questions. So let's start at the beginning, like any good research project. It began with a question, or as we say in science, a hypothesis. And the question really was, why is test automation so difficult? And I think more importantly than difficult, unreliable. And we all hear about test automation being difficult to do, but also very hard to maintain. Unreliable in the sense that automated tests that you write one day no longer run correctly the next day. And that tends to give people the feeling that there's not necessarily a return on investment in test automation, and that manual testing is better, and that why automate tests if they're going to break a week later and require them to be rewritten. And these are valid criticisms or valid concerns, at least, of test automation if it's not done well. And I want to talk about why is this the case fundamentally, and we'll look at, again, some things we found that explain both why it's the case and what we can do about it. So we thought as well, before we get to the Moz500, one of the things we do notice about web testing particularly is that it seems to be a uniquely difficult domain to test. We look at other apps like mobile apps and desktop apps, it isn't quite so bad. So that's why we decided to focus on web applications. So therefore what we thought was, well, where do we find web apps to look at? Let's do some analysis. And it's not just looking at web apps in a static sense, but looking at web apps over time. And we thought, let's look at the most popular applications in the world. And what are those? Well, those are the 500 top websites as ranked by the Moz search engine optimization optimization system. So if any of you do digital marketing or know anyone who does digital marketing, you will have probably heard of things like PageRank or Moz or domain authority or page authority. These are actually all terms that are used when you're doing search engine optimization to see how authoritative a website is. Where does Google rank it? Is it something that Google uses as its top results or something that's down the bottom? And the company Moz provides a lot of tools to help you figure out which websites have got the highest traffic, and they rank those in what's known as the Moz Top 500. And this will show you the 500 most visited websites in any given time period. So what we decided to do was, let's look at these websites. I mean, you can see here things like Facebook, Twitter, Google, YouTube, Instagram, LinkedIn, WordPress, Pinterest, Wikipedia, and WordPress. That's just the top 10. These websites have a lot of money. The companies have some of the best developers in the world. They've invented some of the newest automation frameworks and some of the newest web frameworks, like Twitter invented Bootstrap, Google invented Angular. So when you look at React, comes from Facebook as well. So when you look at web applications that we're building today, many of the frameworks and technologies we're using to build these applications comes from these companies. So whatever they're doing is going to massively impact how everyone else is building web apps. So we thought, well, let's look at these web apps and see how easy would these be to test? And if we wrote tests, how stable and reliable would they be? So what we did, actually, before we get into what we found, we looked at all these 500 websites and we did a crawl of them using some automation tools that we have. And we looked at them not just once, but we took snapshots over time to see how did these websites change. So we basically performed a giant set of test automation on all these websites over time, built some automation scripts automatically using some spidering and bot tools. And then we said, well, let's use that test that we just recorded and try and replay it over multiple time periods to see how reliable they were. And if they weren't reliable, find out why they weren't reliable. And then try and do some analysis to see, how accurate would test automation be against these sites. And the idea being that if we can test these applications well, if there are tools and techniques that we can use to test these well, there's a relatively good chance that those techniques will work for other websites. Because again, if you're using Twitter and it's using Bootstrap or Facebook and React or Google and Angular, guess what? You've probably got other apps using the same frameworks with the same issues and the same limitations and the same difficulties. Okay, so what did we find? Well, we ran this big data analysis. We found that, well, first of all, lots of things we found that you're supposed to accept as true are not the case. So when we write automation scripts, whether we're using a tool or using a framework or doing it by hand, in case doing test automation, one of the problems is we have some assumptions that we hold to be true when we're doing automation. Well, the very first one is, if you look at the W3C, on any given web page, regardless of how many components and frameworks are on that page generating content, IDs are supposed to be unique. It's a basic assumption on a website. An ID does not appear more than once on a page. Unfortunately, we found in our analysis that was not the case. IDs were being reused because you have different frameworks that don't know about each other. Maybe one framework guarantees they're unique, but it's on a page with another framework. Well, they're not guaranteed to be unique across the frameworks. When the browser looks at the page, it just sees multiple IDs that are the same. Once you've got multiple IDs that are the same, IDs become effectively useless as a method for locating pages on the items on the page for test automation. All right. So, okay, first problem, IDs are not unique. So, okay, if IDs are not unique, that's not a problem, right? We have other attributes. IDs are not the only attribute. If you go to any web page, any DOM object, any browser view, of any web page, you should be able to find multiple attributes. So let's look at other attributes. And also, before I do that, I should also mention that even where there were IDs unique, they oftentimes were dynamic or semi-dynamic. So we look here at a web page, and the IDs that exist, a large percentage of the ones that exist are dynamic, or either fully, like just a bunch of numbers, like a session ID, or they're semi-dynamic, like the ones in the middle, the card group or the module. They're repeating multiple times. They're not very useful. There were some IDs that were static, like the footer, the header, the main body. There are some major elements that are static, and we'll come back to that later because that is helpful, but not necessarily by itself. So on the left-hand column, things like footer, leaderboard, footer, else button, headphones, things like that, contactless blocks, anything like that that's static is worth using in automation, but it may only give you access to a block of the page, not a specific control that you want to act on. So it's useful, but not necessarily by itself. Once you get into the dynamic IDs, or certainly even some of the semi-dynamic ones, those are very hard to automate because every time you refresh the page, it might change. And sometimes it's hard to know, is that ID a meaningful ID, like it's an ID of an item that will, in a shopping cart that will be useful, or is it an ID that if I reload the page, it's different next time? Could be both. So the other problems I mentioned there was, okay, IDs not unique, and if they are unique, a lot of random number IDs that are just not very useful. But there are other attributes around. So what attributes can we use? Well, we can use the class or CSS attribute. Now the reason that's obviously used is that affects how the page looks. So web pages that want to actually present information to the user have to use class attributes. It's a way of styling the page. So the good news is they're being used a lot. There's obviously a problem with them. We'll come back to it in a second, but that is good. Now, href, which are links, obviously you have to use those as well to get anywhere. That's useful to know. The problem is that once you get outside of those two, there's not a lot of consistency about what other attributes are being used. And most of them are not being used at all or very little. So things like style and target, right, those are used on links. Source, title tags. Now, title is a great way it's a tooltip. It's a great way of just documenting what something's meant to do. 2% of the time it came up. Alt tags, which would be very useful for finding information because it gives you a way of describing something, not used. Role, which is one of the accessibility attributes not being used. Very quickly, you can see here, not a lot of useful attributes consistently being used across sites, apart from really the top 3 and maybe the style attribute. So basically, class, href, style, and target are the ones that are, other than IDs, that are in use. So that gives us a very limited range of attributes, unfortunately. So for example, if we look at Microsoft Dynamics Central, Business Central, which is an ERP application that's web-based, you can see here that the class attribute is by far the one that's being used across pages. There's almost nothing else being used that much. There's an area label attribute, which you can see here. That's quite useful because it's something that you can put metadata that's meaningful. The control name, there's something called D, and a title tag. So, you could use title, label, and the control name. That would be useful. Class is by far the biggest entry on most elements. So for test automation, what are you going to do? There's very few attributes there to find things. So when you're going to automate clicking on a button, entering text, it's not necessarily very easy to find something that's reliable. So the challenge there right now is looking at this application. This is, again, a typical application by Microsoft. The biggest class you can use, the biggest tag you can use is class. Now, the problem we get into then is if we have classes as the most predominantly used attribute on a web page, that's going to be a problem because classes are being used to style the page, and sometimes they're being generated by frameworks. In this case, it's Google Drive that you're seeing here. So it's not just Microsoft we're picking on. And you can see here, look at these classes. You've got a bunch of letters, A-S-TB. It's all random generated dynamic classes and closures which are being generated here. So it's a giant tree of divs and other elements with lots and lots of random classes. So trying to use class here is difficult because it's W-A-S-A-C-A-I-K-D. I mean, it's meaningless. And it's this giant nested tree of them. So whereas if you were going to click on a button and you hope it's going to be some class like button, unfortunately it's not. It's very random and very generic. And there's lots of them repeating. So that was the other thing we found, that where we are using classes on these large frameworks and large applications, unfortunately, it's actually sometimes hard to use class because there's so many random classes that don't really give you any meaningful information to automate on. And part of the problem why this is happening is that, back in the day when we wrote web apps by hand, you could give meaningful names to things. The problem with a lot of frameworks like Angular, React is that if you're not careful or if you're not intentional, they generate large amounts of tags. They generate HTML tags. They generate large amounts of attributes. They don't put IDs on things. And they generate things in a way that makes it very easy to write the code and maintain it and generate the JavaScript and generate the HTML from these libraries. But it makes it much harder to automate because they're generating a lot of random information that the browser's fine with, but from an automation standpoint, it's not very meaningful. The next problem we ran into when we looked at the data analysis back to the Microsoft example was, even if we have classes that here might be somewhat meaningful, like SPA view, perhaps that's a view we want to look at, what we have also is multiple layers. So what they're doing here is, rather than when you click on a button and a menu comes up, rather than it simply getting rid of the menu and creating the menu the next time, what it was hiding the menu by making it behind. So what happens is if you write a test that uses this attribute and this div and this class and so on, and you try and click on a button, what will happen is the menu pops up. That's great. You click on an item in the menu. That's great. That's your test. Now when you play back the test the second time around, the first menu is still there. The second menu is just in front of it in terms of the Z index, the layer. But the old menu is still there. What happens is the test will try and click on the old menu, not the new menu, or maybe the other one. It's indeterminate. So what will happen is you're clicking on the wrong menu. Instead of clicking on what you think is the active menu, you'll be clicking on perhaps a menu from 2 tests earlier. Again, not very obvious. So that's an issue where you have that. So the other thing also, as you notice here, yet again, we've got 2 forms and 2 IDs of the exact same ID on the same page, which again is not allowed. If we tried to use the ISP.NET form as a control entity to record a test against. We click on it, and actually we're going to click on the wrong one because there's two of them. And again, the browser won't know which one we want. So it reinforces we've got duplicate elements, but we also now have the problem of hidden frames and hidden layers. And the same thing happens on Salesforce. We did a test on some Salesforce apps. You can see the same thing. We've got the exact same button. It's in two different places with the exact same set of items. One is hidden, one is visible. So it can either be hidden or it can be just a different index on the layer. Either way, what's going to happen is you think you're clicking on this button, you're actually clicking on the button from 5 minutes ago that's now hidden. Either way, your test is going to fail when it should pass, or it's going to pass when it should fail. And that creates flaky tests. And once you get flaky tests that don't reliably run, people will lose confidence in your automation. So that's some of the problems we run into is that. Let's just recap. First of all, IDs are not unique. Attributes are not widely used outside of the style attributes, the class attributes, and the href. The class one is unfortunately heavily influenced by the need to present the information to the user, so it tends to change a lot, and it can be dynamically generated to create styles, and it can be repeated. And then the third part was, even if those are not the case, the same element may exist multiple times with different layers, different levels, these indexes, or may be hidden. So that makes it a very difficult job to create automated tests that are reliable. So then the question we asked back is, okay, so that's the world as we saw it. We did this again for 500 different websites. We took snapshots over time, and we watched how those applications both change, but also by reloading the same application many times, we can see which elements are stable or which elements are not stable. If you refresh a page and the ID is the same, it might be stable. If you refresh the page and the ID is different, then it's probably a session ID or some kind of session-specific identifier. Now, what can you do? Now, if it's an application you're building in-house, using one of these or a custom framework or just by hand or whatever it is, one of the things you can always do is ask your developers to actually improve the testability of the app. They can add attributes like ARIA attributes, other metadata that doesn't affect how it looks or works, but documents the items so that users who are doing test automation can actually test it more easily. Now, there are tools that can help you do some of this. So there are automation tools, both open source, that as part of the test automation process will actually analyze the page over multiple trees, multiple sessions, and can actually give you recommendations as to how you should automate it. What attributes make sense, what attributes don't make sense, and if you find there's nothing coming back that makes sense, then that may be a conversation to have for the developers. One thing you can also do is have your developers look at using the same tools you're using. So in the agile methodology, you should be pair programming and pair testing to some degree. And so perhaps you have the developers write the happy path tests using the same automation tool that you're going to use to write the edge case tests on the non-happy path. So as much as possible, if you force developers to try and automate their own work, they'll see the limitations of their own system, and it will incent them to actually do a better job. And that will actually help. Unfortunately, this isn't always possible. There are packaged apps from third parties like Dynamics, Salesforce, SAP, Oracle, you name it, any of the big apps that are out there, Dropbox. If you're automating any application that you don't have the code for, you're stuck. Or maybe it's an application like a Salesforce plugin that you're writing where you can control your piece of the world, your plugin, but it's running on a platform like Salesforce where you can't control the rest of the application. And that can make test automation difficult. And you don't have the ability to refactor, rewrite the code that you're testing. So, okay, so now you're stuck with a world where the automation is limited by the things we've seen, and you can't change the code that's generating these web pages to make it better. So what could you do? Before we get into that, one aside I'd like to mention is, why is it so bad for web apps? Why do we not talk about mobile apps and desktop apps in the same way? Well, one of the reasons actually is if you go back into test automation, when we used to do test automation for desktop apps many years ago, people would write apps using something like Visual Age for Java or Eclipse or IntelliJ. If it was Visual Studio, maybe Visual Studio. There were lots of tools that you'd use to build a desktop app. Similarly with mobile apps, you're using Xcode or using Android Studio. What happens is you're putting in controls and dragging out items and building out a control like a button or a grid or a group by box. You're not hand coding HTML or tags. All of these tools to build out the actual application, and those tools would usually, to some degree, force to put a meaningful name in, to put in a metadata, to put some alt text in. those automation tools that we used to actually write the system, the 4G it needs to be called, those tools would actually enforce good development practices. The problem with web applications is, first of all, you can write it in Notepad if you want to. And secondly, the frameworks, although they do provide benefits in terms of building out UI elements, they're typically being done still in a text editor, where if you're using TypeScript to write React, you're still using ultimately Visual Studio Code or Visual Studio or some other tool to write the web pages. So even though we do have frameworks to make web app creation better, the tools and the IDEs aren't enforcing good test automation standards the way that mobile apps and desktop apps do. So that is why I think fundamentally you're going to get the most problem with web apps. Okay, anyway, so we've talked about what can we do if we have access to the code. Well, we can help our developers do things to make the application better. We can do everything that we saw in the previous slides that they're not doing. They can add IDs that are unique. They can add more attributes that aren't style or classes and so on and so forth. So what if we can't do that? We are stuck with the application that we get. And maybe this application is updating every month, like Salesforce or Microsoft, Office 365, for example, or Dynamics. We're sort of stuck with the application and its update cycle. So the first thing we can do is let's look at some of the examples. So let's say we have a button with a dynamic ID. Here's an example here. It's a button, it's got a random ID, and it's got a span under it with some text. Another example would be the type called button, where it's got this concatenated set of dynamic and non-dynamic elements. So it's part of an invoice. It's got a number, which might be the row, we're not sure, and then some actions tab, and then a button. And the last one is, again, something where you've got a stable bit at the front, dynamic bit at the end. So what can we do? Well, instead of using the ID, we could try using the attributes, class and role and ID. Well, we have type called button. That could be useful, but there is no class and there's no role. Now, we do want to avoid the IDs and classes that are random. So we want to avoid the 3 and the 8, 7, 3, 8, 7, 1, 2 part. We also want to avoid using the full X part of the button. We don't want to go /HTML/body/div, blah, 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 because any part of your page changes, it's going to break your test. So the first thing you might want to do is look to see, can we find an index? Is it like the first button? Or if it's like the second one is the third row of an invoice, maybe we look for the third row in button on an invoice, rather than trying to get the ID of the button. The last option, which is the one that I think people often forget, is text. Now, text is a good option because ultimately the application has to be used by a human. So that button where we see type is button and ID is something else, we don't see here what the text is. The text has got to say something like, new invoice or submit or something like that. So text is really useful because we know it has to be meaningful to the user, therefore it has to be meaningful for the test automator. And if you combine that with like the index and maybe the parent element, so for example, maybe we know that the custom free invoice is stable and we know all the rest of it. And all we do is look for a button called submit in the third row that uses that first part. Now we've got something that's meaningful. It's the third button of a row of a grid that's a list of invoice line items. Instead of simply saying, click on, ID 89EF7, which is meaningless. So looking for meaningful segments of the button itself or the item itself and the parents to it is really helpful, putting them all together. The other thing we can do is some technologies will actually not look for a single ID and a single like XPath or CSS, which is the way a lot of people write their Selenium tests. But instead, let's look at a group of locators. So one of the things I see that's very interesting is when you start to do test automation, when you're a manual tester, as a human, what you're doing is you are opening up an application, you're clicking on things, and as a human, it makes sense, right? It's an invoice, it's got 5 lines. I'm going to add 5 items to my invoice, click add invoice, add item, pick, supplies, it's buying a stapler, all of that stuff. As a human tester, as a test analyst, this is very meaningful. It makes sense to me. Once we get to test automation, we've seen people, it's crazy. You have to become a computer. You're turning humans into computers, basically. You're saying, let me click on that button. Well, let me do F12 in the browser. Let me click on the DOM selector. Let me find out what the ID of the CSS or the XPath is for that button. Let me put it into my Java code. And eventually I'll get, after a lot of time, I'll get an automation framework. But I'm basically having humans behave like computers. Instead, what you should do is have tools, use tools that actually make it easier for you. So when you click on that button, it will come up and say, look, here's the 6 different ways we can find that button. And based on our experience of this page, even loading it twice, a tool could tell you, well, I loaded this page twice for the exact same display, and all these things changed between the two different loads. Guess what? Those are not good locators. Don't use any of those. This last one, maybe the normalized space text equals modules. That's the way to do it. So we need to have tools that basically help humans make intelligent decisions, as opposed to having humans try and pour through large amounts of data and try and make decisions based on incomplete information. So I say test automation is really about an AI, and machine learning is going to be about how do we give the tester who has to ultimately test a business transaction like adding an invoice, how do we help them automate tests in a way that makes it more meaningful for them, versus them trying to use the tool where they have to pour through pages and pages of DOM and XPath and HTML and all this code, trying to ascertain what they should be using in their code. Okay, another example which illustrates the same problem is this one. So we've got this form, and it's got a bunch of divs, and you can see here it's got a button, it's got some spans, and a lot of times when people start to write automated tests, they go to the browser, they look at the button that contains the spans, and they click on it, and they use the browser tools and say, get me the XPath to get to that button. And they copy it from the browser and they stick it in their automation code, again, Selenium code or whatever they're using, whatever framework they're using, and they get something that looks like the top item. And then it works and they go fine, and they play it back a week later in the pipeline and it breaks. And they're like, oh, great. So now you've got a flaky test. And so the problem is you do that over and over again, and now you've got 2 weeks of test automation that's basically throwaway. Versus if you actually either by hand use intelligence to try and figure out what's stable or not, or again have tools that look at it and say, based on reloading this page 10 times with different data, we've determined that the role exists and is meaningful, and the label customers exist and is meaningful in this example. That's the kind of locator we want. And again, it's not necessarily easy for a human to do that on a single look at a page. What you want is to reload the page multiple times and have a computer look at the data and say, oh, this is across these 8 times of loading that page with different data sets, this is what's meaningful, this is what changes, this is what doesn't change. And the next thing would be, how do we deal with hidden layers? So here you've got 4 layers, all with the exact same menu, and they're all stacked on top of each other. So what you need to do basically is use code to basically either use something like the control name, which is meaningful, and avoid the 2 items that have the same ID. And in the case of the case where it's the view with the Z index, we need to add a position last. So again, that means as a test automator, you either have to remember to add things like position last to every single automation code line, right? Or have tools that know, okay, we see 4 layers that are the same, let's automatically add position as last to our recorded locator. So finding ways to reduce the amount of manual error and human coding is critical, because this is complicated and it isn't obvious unless you're looking at this data. Unless you looked at this over multiple loads, you wouldn't see this. You just see one index. Okay, so that's some of what you need to do. Is you need to basically find ways to more uniquely identify the different layers, different items, and make sure that whenever you build a test out, don't just take what the browser's giving you. Don't just put in this top item that you see here and stick it into your code and repeat this for every single button you're clicking on. You need to make sure you understand the changeability of your code, the changeability of the application, and which parts of it are going to live beyond the page refresh. And the other thing will obviously be when you get to cloud applications, the second problem you're going to have is not only does the page change when you refresh the page, but next month, the page might actually change because they can change the actual application. And we do see this more and more. So the second problem is also the time taken to create these tests becomes less useful if the application is changing in ways that break your tests. And we found situations where Microsoft, for example, in their Dynamics platform, every month they're releasing updates. And in those updates, they've literally replaced entire grids with other grids. And to a human tester, they look broadly similar. It's an invoice with line items, so there's line item grid. But unfortunately, to the actual machine behind the scenes, they're completely different grids. There's no commonality apart from data in it. So using things like text probably would work because that's still the same. But things like IDs and styles and attributes were very unreliable. And it was actually really crazy where they would actually put a new grid in 1 month. And then the month later, they went back to the old grid because maybe people didn't like it. And so all the old code would have been useful again. The new code was no longer not useful. So again, it makes automation very difficult. All right. So what can vendors do? And vendors, I'm talking about people who make tools that you're using. This could be open source tools, it can be an internal tool, it could be commercial tools. Um, so I think when we talk about AI, machine learning, I think we're not yet at the point where a machine can look at a web page and say, not yet, and say, I'm an accountant, I understand, how do I create an invoice? How do I add line items? What's a correct operation of an accounting tool? But what I think AI tools and machine learning tools can do is give you, as the test analyst and the test creator, tools to look at the applications and look at the data and look at the pages and be able to suggest better automation strategies. So they can detect dynamic IDs very easily. You run the page 5 times, look for the IDs that change. Simple as that. They can look for the attributes and see how easy is it to find things on a particular set of pages by specific kinds of attribute. They can analyze classes and look for what we call anchors. Anchors are the stable part of a class or an ID. So when you go back to the example earlier on, let me go back to this one. Yeah, here you can see that part of that ID is actually stable. The cost-free invoice is stable. The 3 is not. The accounting actions tab is semi-stable. So you might be able to have a machine go in and see, look at that. I can figure out that the first part and the second part are stable, and I'll ignore the bits in the middle and the last bit at the end, maybe. Again, a machine could run this over multiple data sets for a particular application and see which bits are stable. So the key is scan the application, find the parts that are consistent, find right away which bits will let you find the element. Basically, if you take an element on the page, figure out how you might find it, try and find it. Do you get the same thing? Is it the same? Is it different? Do you get more than one back? Do you get none back? And if that works, great. If not, when you try and run the test, maybe you can find a way using fuzzy matching to find the nearest element and find out if it's the same. And that's one of the holy grails right now, is what's called self-healing tests. That's a test where when you've recorded it or built out the test and you play it back, the system can handle slight changes where the change is not material to the test. Now, obviously, that's a dangerous piece because you might end up passing something that has failed. Because when something has changed, how much does it need to change for it to be a failure? Like, we thought clicking on this button would do something. Well, it does something different. But is that different the same different or different different? Is it passing or failing? And that's obviously a dangerous part. If we make the margin error too great and then it's too fuzzy, we might be creating false positives, things that actually pass when they really should have failed. The reverse is true. If we're too specific, we may end up with lots and lots of flaky tests that are very susceptible to unrelated changes in the application. All right, so how can we do things? So there are some things you can do. One thing you can do is get a list on a page of attribute values and sort them and see, do we get duplicates? Do we get repeats? Do we get consistency? Look for those kind of cases. The other thing we can do is we can look at, in this case, we're looking at 2 different sales accounts. So we're looking at one sales account and a second sales account. They're 2 of the exact same pages, but with different data elements. So one is customer 1, one is customer 2. But it is the same page. Compare the 2, because you've now got an interesting case where you've got 2 different customer records, but it's the same page layout. And if you put those together and compare them, you will now find which elements are the same because there's a different customer ID, different invoice ID, and which parts have changed because of that, and which parts are the same. Then you can load the same page twice. So what you're doing is you're comparing 2 loads of the same page and 2 different pages, 2 different versions of the page for different data elements. Now you'll see which parts of it changed because the business changed, different customer, which parts of the page changed because it's random, it's a session ID, it just changes every time you load the page. And thirdly, you'll know which parts didn't change in either case. Doesn't matter if you change the customer, doesn't matter if you refresh the page. So you now know which parts are stable for that type of page in general, it's part of the page template. You know which parts of the page do change, but change based on business metrics, business ID, like customer ID. So that's useful to know. And the third part is which part changed randomly and should be ignored. And that helps you build out queries and locators that are going to work across multiple customers, but also understand what customer 1 means as distinct from customer 2. And the other thing we can do is we can look at which attributes let us find things on the page. In this case, we can see that for this particular application, there are basically 4 attributes we can use. Sorry, 5, including class. And that may be different for your application. So what we need to do is use these tools for each application we're testing to figure out which attributes we should use and how we should identify them using these attributes. And then what we can do is we can then define standard anchors like menu item, maybe it's in this case, the menu item, it could be the view, the SPA view tag you can see here. There's pieces of the page that we've now found that are stable. We loaded it multiple times. We loaded it with multiple customers. We know what's an anchor. That's a part of the page that doesn't change, even if the data changes, even if the page is reloaded. And we can then append onto that the part of the page that changes when the business changes, when the customer changes. And we can completely ignore the parts that are changing randomly because the page just reloaded, but it's the same customer. So we've now got these anchors and elements that we add on to that to come up with locators that are going to be business specific, application specific, but are stable for that application. And if we do our job well, the system will be able to know what's a meaningful change, what kind of change should we expect. Like in this case, the word username became user space name or vice versa. And the system can actually use these different locators and different techniques, put them together and see, do we think this is a match? It's a 94% probability using these different statistical methods together. So and this is again using one of our tools that we used to actually do this analysis when we did the analysis. So the next thing would be, okay, so if we know that this particular application, say it's Salesforce, say it's Microsoft Dynamics, let's say that we've understood this application, we understand how this application is put together. We've loaded multiple pages multiple times. We've tried it with different data elements, different customer IDs, invoice IDs, whatever it is. And what we now see is we now know this application at its current point in time, until the next update at least, how does it work? So we can now build out a profile. This is what we call a web application profile, just a JSON file that's used to document it. Now, this could be built by hand. You could go in here and say, okay, based on my experience, I know that the IDs should be ignored if they're numeric, and if they're empty, we ignore them. I know that we should use name, title, href, role, because we know those are useful. However, if you look at that analysis we did earlier on, where we're doing this systematically, we're using a tool to do this. We're actually calculating which attributes are useful, which attributes should be ignored because they're on very few pages or they change every time. Because of that, we're able to automatically generate the right profile for an application. So what we're doing is we're basically modeling the application. And then once you do that, the system can now suggest to you, based on this application that it knows, what is the right way to locate the button, the link, a menu. But you're not doing it every single time. You do this once for the application itself, for say Salesforce, and now every time we record it or build a test using Salesforce, we know it's going to be stable. Now that doesn't mean you can take that profile and then use it for say Dynamics or SAP. They will do their own profile because we know that each application is using different technologies, and even over time these profiles will change because the applications unfortunately do change. Updates come every month. So just to go through to wrap up of what we talked about, first of all, when we did a look at the 500 most popular websites using some of the most innovative and latest frameworks like Angular, React, Bootstrap, and things like that, we found that the problem is massive. We found that most of the standards that the web is supposed to follow aren't being accurately followed consistently. IDs, attributes, and in fact, the use of these frameworks has often made it worse because people are no longer generating code by hand or even looking at what's generated. These frameworks generate everything without a lot of thought being put into what it looks like in the browser behind the scenes. We also thought that we talked about how if you have a development team that has access to the code and you're building this application, you have the ability to make it better. And then when the cases where you don't have ability to change the application itself being tested, in the terms of current technology, there are tools that can help you analyze the web page so that rather than just simply blindly taking what the browser is telling you is the right way of locating an object in your browser using F12, there are some tools that can look at the browser, look at the page, look at it both once and over multiple times and see what's stable, what's transient. And then, as we said, in the future, what we're going to see is more and more AI/machine learning. And really, it's machine learning, it's not AI, where they're going to look at large amounts of data like we did in this research project, but they're going to do it in real time. They're going to look at your application, scan its pages, scan through every variation of the page across different data sets, like every customer in the database, and then determine how to find things on the page. That doesn't mean the AI is going to come and say, I'm going to do this test for you. But what it will do is hopefully make automation feel more like manual testing, where we as a human who understands testing, we can focus more on edge cases. We can focus more on the business being tested. Are we testing all the right types of customer? Are we testing the right kinds of data? And less time on the mechanics of testing, less time spent building tests, building frameworks, dealing with flaky tests, fixing XPath, fixing SCSS, more time on understanding, did we test this for XSS? Did we try SQL injection? Did we think about a customer that's been deactivated? Thinking about the bases that really stress the application and less on the mechanics of it. And hopefully that will mean we're spending more time automating tests than on test automation itself. And with that, we're a little bit ahead of time. I'm going to hand it over to questions. So if you have any questions on the presentation, now is a good time. Let me stop sharing. Hold on. Where's that gone? Oop, stop sharing. Great. If you have any questions, please write them in the window to the right. Let's see. So first question, there's some comments. Is it possible to show the screen any here? All the samples. Okay, hold on. What is the advantage of test automation? So I didn't go into test automation. Now, test automation, the advantage obviously is it's faster on after the first time around. So, for example, let's imagine here, a good example would be I want to log into an application that we built. I need to log in on Firefox, Chrome, Safari, maybe Opera, Edge, maybe IE, still probably not IE anymore, but let's say 4 to 5 browsers. When I log into the application, I can log in with 10 different types of user. And when I log in, I need to make sure that these different 10 user roles can only see the right parts of the application. Now, a human can do that. You can obviously open a browser up and log in and see what tabs you can see. Imagine doing that. It would take you maybe, I don't know, 2 or 3 hours. It's incredibly mind-numbing, incredibly boring. Probably what will happen is, one, you'll make a mistake. Halfway through, you'll forget which browser you're supposed to be using, which tab you're meant to be using, or you'll skip a tab. As humans, boring, repetitive tasks are the worst for us. A, we don't like them, but B, we're not very good at them. We tend to forget what we're doing. We tend to make mistakes and either forget a tab, think we saw a tab and we didn't see a tab, all that. So false positives and false negatives. So that's a really bad use case for manual testing because we're going to make mistakes and it's boring. And then let's say you change something in the application to fix it. Well, now you're going to retest it again. Now you're going to tell those testers who just spent a day doing really boring, clicking around and looking at tabs, do it again for me, please. Oh my goodness. So again, not a very good use of time and not very reliable. That's a really good candidate for test automation because you could write that, script it, run it multiple times. It's not a particularly complex flow, lots of data to try out, 10 different users, 10 different, 5 different browsers, 50 combinations basically. That's a really good test automation use case because you'll spend maybe, I don't know, half a day writing it and maybe 10 minutes running it. So that half a day investment is really worthwhile. However, let's say you've got to do a different kind of test. I've got to create a very complex sale order that will take me as a human 20 minutes to go through all the clicks and all the steps. But I only have to run it once for one user in one browser. Now, it may take me 20 minutes to do it by hand. Automating it might take me 2 days reliably. I'm only going to play it once a month. The ROIs may not be there, and the application is changing quite a lot. Now you might find that manual testing is better. Humans are really good at that kind of test. It's one where we're not doing the same thing over and over again. It's not boring. I need to look at this page. I'm trying this complex flow of multiple steps. It's testing what a user is going to be doing in that flow. Perhaps that should be manual tested for a while, at least until we're going to do more of it. So those are two extreme cases. The first one is really good for test automation. The second one is really good for manual testing. And if you only have a certain amount of time, I would say automate those kind of first tests, get those done. And then obviously, if you get those done and they're working, they're stable, delivering value, you can then move on and do some of the other tests that are more complicated. Okay, so that was that question about why, what is the advantage of automated testing? The main advantage is you want to automate repetitive, boring tests that involve a human being very careful in a way that is not conducive to the way we humans think or act. And that's where automated testing is really good. Any other questions? I don't see any more. So Thomas's talk is going to be in about 15 minutes. So let me check. Again, if you have any questions, please feel free to write them. While we're waiting, one question I often get asked is about test automation anyway, is, should I use commercial tools? Should I use open source tools? What's the benefit? So that's always a contentious question. I mean, it's interesting. One of the statistics I read, which was very interesting, was that with open source frameworks and Selenium, more and more companies are doing test automation than ever before. Back 12 or 15 years ago, you were using tools from Mercury and things like what's it called, Quick Test Pro, UFT, Test Complete, things like that. Commercial tools that do test automation, and they were expensive, and they obviously require you to buy a license, and they were proprietary, and you couldn't move your tests, and so on and so forth. And I know Selenium is good because it lets anyone write tests. One of the statistics I found that was very alarming, though, was they say that 90% of people are trying automation and 80% are failing. So have we actually improved the state of the art, or have we simply created more and more tests that are not delivering value? So that's one of the challenges when you do a test automation, is that one of the benefits of some of the commercial tools was that they did guide you in the testing, and they could guide you into writing tests that were perhaps more maintainable. One of the challenges we've seen with test automation frameworks is because we often integrate with them. So one of the tools that we sell is a test management tool called Test that integrates with automation tools. And that unfortunately means that we get to hear about all the horror stories of automation frameworks. The problem we find is that as a company, don't let someone go off and write their own automation framework by themselves. Because what will happen is, when you're writing an automation framework, it's fun. You get to build this code, you get to go online, you get to research, you get to build this object model using JSON files. It's going to be very abstract. It's going to be very maintainable. It's really good. However, when you leave the company, what will happen is no one knows how you did it. So if you're a manager and you're going to have team do automation, I would seriously look at open source versus commercial. There's benefits of both. I'm keeping out the politics of that. There's pros and cons. If you automated tools that are commercial will often have pre-built libraries for Salesforce, Dynamics, SAP that maybe take some of the error out of it. They do some of the work for you. They have some intelligence. The vendor will obviously provide support. If the person leaves the company, you get support. It obviously means you're also tied to that vendor, tied to that license. That's the downside. Whether it's open source or it's commercial, however, what I would say is, make sure you have a team do automation. Make sure the knowledge is dispersed so that people keep checks on each other, so people don't build effectively a job for life. If someone leaves the company, you're not left with an unmaintainable framework that no one remembers how it works. And we see that time and again. Someone built this great automation framework. It really worked. The team loves it. It's working every day. The person goes to work somewhere else. The application that's being tested is changed materially. The framework stops working, and they throw the entire framework away and start again with another one.